hear me? You hear me? Okay, let's go.
Okay, CK. I think we can start for benefit of people who are already joined online. Can you hear me well? Right?
Yes, yes. Can you hear me?
Okay, perfect. Yeah, yeah.
Great. All right.
All right. I will give the ball to you. You can start with your introduction first.
Sure. Thank you so much, Manishi. Thank you and good morning. First and foremost, good morning to everyone. Some of you might be already nearing half of the day, so probably a good late morning to those who are there. All right. My name is Chi Kyong Lim, as you can see on the board. Most of the people who know me will just call me CK for short. So throughout the whole presentation, if you do have any questions, just call up to CK and then you've got a question or raise your hand and feel free to ask. All right. So I'll try and answer as much as possible. Now, just for the benefit of those who do not know me yet, I'm actually the zone solution architect for the healthcare segment, as well as, for digital energy for data center. So I'm actually the one that is providing solutions, what I call to the entire EAJ zone, East Asia and Japan for healthcare as well as data center. So that's what I do. So today, I think thanks to Manishi for organizing this short presentation, to actually introduce what healthcare segment is, to all the participants today. I think on day one, I've actually come up or actually I've produced an introduction to the overall overview of what Schneider has for healthcare segment. And I think on the same day itself, you probably have gone through a lot of other products. So today we are going to concentrate a little bit more in what we call the digital energy realm, or in other words, is the integrated building solution and how is it being applied to the healthcare segment. All right. So for a start, let's have a look at the agenda that I have prepared for the next 1.5 hours to two, depending on whether there's any questions coming along. So we'll look at the healthcare segment as it is. All right. Then we'll have an explore of what EcoStructure is. Schneider's EcoStructure is a trade name or is a brand name, or you can call it even a platform. How is it being adopted or being applied into healthcare? Then we'll move a little bit more closer into what we call the building management system. Here, I would like to expand a little bit. When we talk about building management system, it's actually an integrated solution. So that's where we move into the next section. We were going to explore a little bit of what is integrated healthcare infrastructure. All right. Then we move on to analytics. Finally, we move into cybersecurity. And end of the day, we have a look at the future of what I call healthcare. All right. So, hang on. Sorry. I've called up the wrong deck. Give me a moment because I've just done one deck yesterday, so I'm sorry I've called up the wrong one. Give me a moment. Yeah, okay.
That's okay.
I'm so sorry about that.
Friday morning for everybody.
Oh, you've said it.
No, it happens.
Yeah, this would be the right one. I'm so sorry about that again. All right, so let's move. Yeah, it's
No,
pretty much going to be the same thing.
CK, we can't
Sorry.
see the screen. Can you please share?
That's strange. Okay, hang on, hang on. Now can you see?
No.
Hmm. What about
Yeah,
now?
perfect.
Okay, I'm so sorry about that again. Like Manishi said, it's Friday morning, so the time clock is running a bit bad. Okay, so let's look into for today, right? The agenda will be we have the Schneider Electric story, how where we are. We look at digital energy, we look at the intelligence systems, and we move into analytics, and pretty much the rest of it, is talking about cybersecurity and what are the things related to an integrated hospital system. I think one of the more interesting topic would be topic number 7. We will take a short look, at what the future of healthcare is going to be like. All right. So let's move forward now. I think for a start, before we go anywhere, I'd like to show a short video to share with you what is Schneider. All right, because the key thing is that in the last couple of presentation that I've had with clients and consultants and so on, it seems that there's still a bit of a confusion who Schneider and who Schindler is. All right, so let's have a look at this one. I'll run through the video just to put us on the right track.
The world is full of people telling you who to believe they are. Well, we thought we'd tell you who we're not. Let's start here. We're not in shipping. We don't make lifts. Seriously, no lifts. We do this. We're good at this. And we make all of these. And even though you'll find us here and here, we don't make energy. We make you save it. And you'll be saving the environment too. Are we an internet company? Well, we connect and power just about everything around you, helping machines talk to each other and to you, making your world more personal. We're seeking out the big questions and answering them honestly. Like, how can we make the most of our energy and resources? Or can we make access to energy and digital basic human rights? We're real people, employees, developers, partners, investors, and all passionate about doing what's right. We're open. Humans of all sorts from all over, learning from each other and about each other. We're not here to save the world. It'll go on with or without us. We're here to help power and connect what you do every day, to ensure life is on everywhere, for everyone at every moment.
All right, I hope, I'm sure some of you would have already seen this video before, and some of you who might not. The reason why I'm showing this is how Schneider is related to healthcare, because Schneider does a lot of things. It's one of the few big companies in the world today that we are offering solutions to pretty much all the buildings that is available in the world today. We talk about retail, we talk about pharmaceutical, we talk about life science, and so on and so forth. So for Schneider, we are one of the few companies who can offer end-to-end solution. And for me, healthcare is one of the big thing that we go. The motto for Schneider is very, very well connected to the healthcare segment, because life is on. All right. For us, when we talk about healthcare, we are always dealing with life. We try to ensure and maintain that we can, as long as we can preserve a life, help to preserve a life, we should be doing it. And that's what Schneider is here for. One of the key goal is to ensure that today, our civilization, healthcare is well being taken care of, especially in the current condition that we are in. Many people that I've spoken to in the last couple of months is telling me that, there's light at the end of the tunnel. To be honest with you, today we still do not know yet. We are definitely moving into the of the pandemic that we are facing, but are we really going to be out of it? We are not. But one thing is for sure, healthcare is here to stay, and it's even going to be more demanding than ever. All right, because the pandemic that we are seeing today will not be the last. I'm pretty sure, or rather experts have been saying, pretty sure there'll be another one. We need to be ready for it. So that's the reason why, we are very passionate about healthcare in Schneider Electric. All right. I think when we talk about trend and challenges, we've touched on that pretty much in day one, right? Over here, when we go into the what I call integrated healthcare solution, again, we need to start off with the 4 basic principles from Schneider when we are doing any design or when we are doing any solution. We talk about people-centric, we talk about hyper-efficiency, we talk about resiliency, we talk about sustainability. All right. I think probably for the last 2 days, a lot of my fellow colleagues have already gone through this in a different domain. So today I will use the same pillars. We'll move into the digital world, or what I call interconnected world. Let's have a closer look at what we mean by the 4 pillars when it comes to healthcare. We talk about resilient, all right. I think a lot of people will have asked me, why are we talking about resiliency and we are not talking about redundancy, all right. So for today, we need to really look at the key difference between these two terms. Okay, if we talk about redundancy alone, we are only talking about N+1 or backups. All right, but does it really deal with the word resiliency itself? It's not. All right, in the Schneider's term, when we talk about resiliency, there's actually 4 or 5 categories that we actually look at. Redundancy is only one part of it. All right. Other areas we should be looking at recovery, we should be looking at robustness of the system, we should be looking at the resiliency, and also what I call the availability of the entire system. Only when we cover all that 5 areas, all right, we can say that the system is resilient. I'll give you an example. If we talk about redundancy itself, I can have 2 systems running, or maybe 2 equipments running, but if they are not connected to one another, or if they are not talking to one another, when one fails, the other one doesn't know what to do. We have redundancy, but does it really work? It's not. So instead of talking about redundancy alone, we should be addressing the real issue behind healthcare is resiliency. How resilient is the system that we are providing? All right. The next thing is we are looking at hyper efficiency. All right. The system have to be hyper efficient. I think I don't really have to explain too much because most of us know in a hospital environment, especially in the critical environment when we talk about laboratories, when we talk about ICU, we talk about operating theater, no system can fail because any glitch in the system will probably result in the loss of life. And that is something that in any healthcare facility, you cannot have it. All right. Then we talk about sustainability. I think today, everyone will be hearing, even in probably the next couple of weeks down the line, we are going to hear a lot from world leaders when it comes to the COP26, what I call gathering itself. We are always concentrating, or today there's more concern in terms of carbon footprint. Everywhere around the world, we need to reduce carbon footprint. When it comes to healthcare, healthcare is one of the worst culprit when it comes to fossil fuel utilization, and that's where healthcare itself, leaves behind a big carbon footprint. So how do we address that? What do we need to do? Schneider is here, in fact, to provide solution to help alleviate the issues. When we talk about sustainability, we talk about alternative energy resources. Because today, most of the electricity they are providing, we are burning coal, we are burning fuel, we are burning gas. And that's where we leave behind a large carbon footprint. We today have the technology to harness other energy sources, alternative energy sources. For example, solar, wind, hydro. So in Schneider's perspective, we do provide the necessary system to allow our users or whoever there is working together with Schneider to actually harness these alternative resources, which is available in different countries and different parts of the world. So in order for us to make sure that the healthcare system is workable, it needs to be sustainable, it needs to be eco-friendly. So one of the key things when we talk about sustainability is harnessing alternative resources, green resources, as well as recyclable resources, right? Coming back to healthcare, when we talk about sustainability, there's one more area that we really need to look at, and that's actually the safety of the environment. Why do we say so? Most of the other buildings that we find, probably shopping centers and so on, we only deal with carbon footprint, right? But in the healthcare environment, right, we talk about one thing extra, which is infections. I think a very good example would be probably about 22 months ago, right? Probably on the 31st of December, somewhere in China, we realized or we noticed a single case of infection, a single case of probably flu-like symptoms. During that time, because of knowledge, because of what I call unfamiliarity with the thing, there was no proper containment being put across to contain this area. 22 months later, today, there's about 240 million infections around the world. The point that we are trying to highlight here is that apart from the normal carbon footprint that we are talking about in sustainability, in the healthcare environment, we talk about protection of the environment as well. And that's where we talk about containment. All right. So whatever solution that we provide for healthcare, for a hospital, apart from energy saving, apart from all the alternative energy uses, we also need to make sure that the environment is properly protected and contained because we are dealing with viruses and bacteria, which is going to harm life. All right. So there's this extra spectrum in terms of sustainability for healthcare that we talk about apart from energy is containment and isolation. All right. So next, last but not least, is people-centric. Every system in healthcare that we put across is meant for human. It's not for anything else. It's not for animals. It's not for machine. It's not for anything else. It's purely for human. That's why we call it healthcare. Because if it's for animal, it's going to be called veterinary. All right. So when it comes to healthcare itself, people is the key. Whether it's the patient, all right, it's very important that we make sure that sick people gets well in a safe environment. At the same time, we also need to talk about the people who are running, the caregivers. Those are the frontline heroes that we have today. All right, you can hear today, we have so many cases that are coming in where healthcare people are actually dropping like flies. And these are the people that is going to treat any one of us who is sick. So the system that we put in have to ensure that they are well protected as far as possible so that they can continue their work itself, to make sure that all of us are safe. So whatever system that we put in is all about human. Be it the patient, be it the user, be it the visitors, be it anyone. End of the day, it's the human. So all the systems that we are putting in has to be people-centric. So these are the 4 pillars or the 4 guidelines that in any system that Schneider does or solutioning that we provide, we will have to follow and bear in mind. All right. So let's move forward. Now, having said that, having understood the fundamentals behind it, let's have a look at the infrastructure. Okay, Schneider Electric, as you have seen in the video itself, we are not any of those what they call food and beverage providers, etc. We are actually infrastructure service provider. And when it comes to hospital, infrastructure of a hospital is very, very important. A hospital is just like a human body. All right. A lot of you would be asking, why am I showing this? Because we are talking about technology. The reason, the correlation between a human body and a hospital is actually like a human body. Every single part of the human body, regardless of whether it's the bone, the muscle, the nervous systems, or even the what they call the regulatory systems, every single one of it have to work proper. Otherwise, the human will be sick. Likewise, in a hospital itself, especially in critical environment, every single infrastructure, be it the power or the air or the ICT or the security, everything needs to work correlated, hand in hand, and in proper condition. Otherwise, the facility will fail. And when a facility fails, it's not only going to affect lives, it's going to cost life. Right? So having this understanding in mind, let's relate to the real world of hospital. In a hospital, there are multiple systems. It is just like a human body. There are so many different parts that you can see within the slide here, and this is just some of the systems that we provide in a hospital. And all these systems needs to work properly. And how do we do that? It needs to be monitored, it needs to be controlled, and it needs to be integrated to work hand in hand so that the hospital can function properly. Okay. So that's where we'll go into the next phase. We talk about Schneider Electric in terms of digital energy. In the last 2 days, probably you have heard about the UPSs, you have heard about the power, what I call supply or utility. Today, we are going to look into the digital realm, of the healthcare segment or domain. All right. I think for the last 2 days, probably you have already seen the architecture of Schneider Electric. Normally we have the 3 layers. Likewise, in healthcare, within the 3 layers of all the products, we go across the board. We are covering across the entire spectrum from grid, power plant, machinery, buildings, IT, and all the way across. So every single one of this portion has a place in the hospital. So through the 3 layers of integrations that we have, we are able to provide services to the entire spectrum of the healthcare, which covers acute, specialist, inpatient, outpatient, even silver age. So silver age here means old age care, right? Just for those who are not familiar with. So when it comes to EcoStruxure itself for healthcare, this is the fundamental architecture that we provide, for healthcare. Let's move on. Let's look in a more detailed environment. We talk about power. In any hospital, if there is no power, hospital will not run. All right, I think we all know in any advanced facility, no matter how good or how advanced or even how highly adaptable they are, without power, nothing works. And just for your information, most of you will know that in Schneider Electric, we are one of the few good power companies, or I won't say power company, power system providers that is available in the world today. Right? We may not be the best, but we are definitely among the best. So when it comes to power, we are very passionate. We have more than 100 years of experience, and this 100 years of experience, when we apply to healthcare, can pretty much cover most of the issues or most of the gaps that you can find within a hospital. Let's have a look in more details. When we talk about the entire power, we can actually address, like what I mentioned, coming down from the grid, down to the distribution, to the MV, LVs, all the way down to the monitoring. Now, how does all these things relate to digital energy? Because every single step of the way, or every single process, be it the architecture overview, the equipments, the connected product, every single one of these can be connected in the digital realm. So that is where we actually talk about IoT. Most of the device within Schneider itself is IoT enabled. So when we are able to connect all this equipment, we can actually provide a full picture of how the power performance is, not only in terms of distribution, not only in terms of just supply, we can also address issues like reliability, we can address issues like quality. How does this relate to the real world? In a hospital, we always talk about critical environment, utilities and so on. Right? We talk about power availability to this area. A good example would be operating theater. You do not expect the doctor to stop the operation when something happens after he has cut the patient or open up the body, especially if it's an open body surgery. That will not work. So we need to ensure that the utility towards the operating theater needs to be running all the time when the operation is available. That is common knowledge and that's common sense. However, there's other areas that we should also be looking at, because today, healthcare is very highly advanced. In the past, we talk about X-ray machine, we take a photo, then we take a film, the black color film will go in, the doctor will decipher. But today is no longer the case. A lot of the equipment that we can actually see the entire body from the skin all the way down to the minute, components of the body or the functioning or the organs of your body, be it the heart, the liver, and so on. We do have things like what we call the CT machine, the MRI machine, and so these are very highly sophisticated and expensive equipment which require very good quality power. So without good quality supply of this power utility, we are actually reducing the life of the equipment or the asset itself, which is very expensive to the hospital. More importantly, it can actually create risk, or danger to a patient, because borderline quality power supply to this equipment may yield or result in substandard outputs, which will result in the mild, what I call, diagnosis of a doctor, and that is actually a danger to life. So what I'm trying to say is that you must have good, high quality, reliable power to these precise instruments within a hospital. And this is not only there's not only one equipment that's available. Like for example, CTM, there are multiple. So we need to ensure that the entire supply of the power to this equipment is really crisp, in wherever the supply. So when we go back up to look at the overall of the power system, all right, all this equipment, all this power needs to be monitored, regulated, controlled, and ensure that proper backup is available. So that's how big the power system can be, all right. The slide that follow up on here is very strictly unique to a hospital environment. Like I have mentioned earlier on, in an operating theater environment or in an ICU environment, we cannot have the possibility of a power failure. All right. So in the healthcare environment, we do have this solution. It's not unique. It's not unique to Schneider alone, because this is what is required in generally in the healthcare environment or the healthcare segment itself. But definitely in Schneider, we do have a solution, right, that addresses the requirement of the IEC standard, right? And this panel in itself is actually what we call an isolated panel, right? What it does is that if you have certain form or small amount of fault that is detected within the operating theater, be it during an operation or during otherwise, this panel will be able to isolate, but it will not cut off the power to the environment itself to ensure that the operations or the procedure carry on. Right? So this is what we call an isolated smart panel. All right, this is one of the solutions that we do have. Like I said, today I'm not here to share with you the actual nitty-gritty behind all the individual product, because in Schneider we have multiple products and it's going to take me a long time to actually cover all this. Over here we are just going to give you a snapshot of where we are and how it is being digitized. So with this panel, when they are properly connected, when they are integrated to our power monitoring system, you can actually monitor the entire operating theater within a hospital, be it 10 operating theater, 5 operating theater, or maybe 30 to 40 operating theater at any one time, to give you an overview of how operating theaters are being utilized, all right, or are being used, and what is their condition. Most importantly is what is their condition, right? Now, even within the operating theater, if something were to happen, this panel will be able to isolate. What I'm saying here is fault isolation. We are not talking about big trips and so on, but it's purely for fault isolation so that all the operation can continue. Right? So this pretty much covers actually what power is available and what we can do with the power, or how we can monitor the power. Okay. Next thing, of course, when it comes to a hospital, we are talking about building. We are talking about mechanical control. Right? So very often when I meet with clients and so on, most of them would know about Schneider as power. We have very good power systems, but not many, or I would say a fraction of the clients that I've seen do not actually know that Schneider do provide BMS system as well. In fact, we do. Right. So in building in Schneider Electric, we do have BMS systems, and in fact, we actually cover IoT-based systems. In other words, the entire systems can be actually IoT-based, because in the market today, we are seeing a lot of combinations of IoT systems with what we call the MSTP connections. But in Schneider itself, we do have a full range of IoT BMS systems. Now, some of you would probably be asking, why do we need that? In a hospital today, when we talk about integrated control or we talk about mechanical control,
we do need to have a lot of control power. And if we were to fall back on the traditional MCP kind of connection and so on, the speed, the reliability, and the resiliency of the system is not that great compared to IP, because in IP, we definitely know there's a big bandwidth. We can actually produce or send across huge data that is very, very well needed within a controlled environment, especially critical control, right? So in our system in Schneider Electric itself, when we talk about BMS, we actually have a freely configurable IP-based system, which is technically, as what I call flexible as an IT system that you can provide. Now, in the BMS system, when we talk about, we are pretty much talking about mechanical control. And within the mechanical control, we are talking about air quality, pressurization, temperature, and humidity control. I think yesterday I've actually gone through a short presentation with one of the consultants where we actually explore how we did that, but because of time constraint today, I'm not able to go into very in-depth or very in detail, of all this control. But nevertheless, in Schneider Electric itself, when it comes to the BMS, we are able to do all this air quality, pressurization, temperature, and humidity control, not just monitoring it. All right. Going one step further, in any hospital, security is of high requirement. I think today, when we go around any hospital, security is even more important compared to the rest. Today, when we are talking about security, we need to talk about not only what I call entrance, we also need to talk about egress. The important thing when it comes to security for today is actually today the pandemic showcases the importance of this security, because today we need to know who is coming in and who is going out. I'll give you a good example. Like for example, if you move into a normal what I call administrative area, all right, this patient comes in with flu-like symptoms, right? He could be having fever. In the past, nobody would really what I call pay any attention to this person. It would be just a common flu. But today is a totally different story. The moment this person comes in with the symptoms itself, he needs to be tracked from the day he enters the ward, he enters the admission area, all the way down to his exit. He or she needs to be monitored, and to a certain extent, he or she needs to be constrained in terms of movement, and as well as in terms of areas that he or she can go to. And that's where security will have to come in. Be it whether you lock the area that he's moving through, or whether you are putting a wristband on his hand to monitor he or she, where is she moving, all right? So security to a large extent is actually to provide access resistance as well as monitoring the movement of all these patients. So in Schneider Electric itself, we also have what we call the security card access systems, which is being shown on the screen now. So with this system, we can actually provide a comprehensive solution to actually monitor the entrance or the exit of all the patient, or who are the patient that is actually staying there. Okay, that's just one of the example. Another good example would easily be, for today, I think babies is a very expensive commodity. I think today, because of our lifestyle and so on, unfortunately to say, there's a lot of parents who are unable to give offspring, and every single one of these babies is the most precious thing, and it's priceless. But throughout the years or throughout the history of healthcare, we have already heard that normally in the hospital, sometimes, very often, especially in countries that are less advanced, we do hear that pregnant, what I call parents who goes into the hospital, when they leave, they do not have their babies with them. So this is where security comes into play. All right, it's very, very important. We can actually tag the baby to the relevant parents, so that the moment the baby arrives in the world today, they are already being tagged to their parents till the day they leave the hospital. So to ensure that they really go back with their parents and have a good life ahead. So that's how important security it is today, and we do have a system available to address all these issues. So this is where we are looking at when it comes to security. All right. So apart from that, when it comes to security, we also talk about a lot about what they call the accesses. Okay, we talk about we talk about all the applications. What you do, facial recognition. In hospital, very important is fall. You can have old folks or very sick patients who are falling. So in the past, I have also come across cases whereby a patient could fall down, or probably during an emergency where there are a lot of patients coming in, some of the patients would probably have been, I would say, left aside for some time. All right. So when it comes to the security system, we do have applications or analytics that actually detects all these non-movement fall, sleep, and so on. All right, so we can actually do that. So when it comes to the security system, when we apply all this together, okay, we can provide more, coverage as well as safety to all the patients, including the staffs. All right. Now, having said that, when we talk about digital system, we talk about BMS, we talk about monitoring, etc. We cannot run away from IT. Right. I think today, again, the expenses in IT when it comes to the digital hospital, the amount of bandwidth that is being generated is super high. All right. And that is where when we talk about it, we really need to address other issues like storage, transmission, as well as how reliable is the network. Okay, so a good example is when we talk about data today, when we talk about, like I mentioned earlier on, when we talk about X-ray machines, in the past we are talking about film. Today we are talking about digital X-ray, and comparatively, every single digital what I call digital X-ray film actually uses up a lot of data bandwidth. In fact, data storage that is required, not to mention the MRI machine that can scan the entire body, or the CT CATs, the CAT scan that actually gives. So all this actually contributes to data usage and data storage. COVID-19 has actually made another area of digital movement, or digital data increase, and that is telemedicine. I think today most of the doctors that you talk to, if you're in this field itself, you would come to understand that doctors would normally not like to be as close as possible to the patient, in a sense that, of exposing themselves. All right. So very often when you go to the GPs or the specialists, they would probably what they call interact with their patients through telemedicine or through the screen. In Singapore today, there is actually a pilot project that is going through where doctors actually provides medical care, medical facilities to patients, to COVID-19 positive patients, through telemedicine, because most of these patients in Singapore today, they are actually recovering from home. All right, for them to move to their doctor, or for their doctor to be able to see them and monitor their progress and so on, is kind of difficult due to the restriction in movement. So that is where telemedicine comes in. Right, so we can have face-to-face, what I call checking, visual observations of the patients and so on through the monitor. All right, and that indirectly increases the bandwidth, increases the data, increases the height, the digital power that is required to run. And from there, most of the hospital today, or the newer hospital that I've seen, will actually plan in a data center. All right, and when we talk about data center, the tier requirement of a data center will come in, not to mention all the backups, all the networking, and so on. So in Schneider Electric, we do have a solution for data centers. All right, that is where we have our DSIM, we have our rack system to put in your servers, we have all the cooling units to maintain either a real full-fledged data center, or maybe just a simple server room to cater for, depending on the size of the hospital. All right, so when we talk about end-to-end solution, we need to address from the power all the way down to the mechanical, to the security, and last but not least, the in thing for today, the data requirement. All right, this is in where data center will come into play. All right, so having looked at that in a data center, we do have solutions when it comes to secure power, which is the UPSs that it needs to put in place. All right, you need to have the cooling units in case the main utility or the main AHU from the chiller plant fails. You cannot have completely no cooling within a data center, because that will kill the servers. So we do have standby or backup cooling units to be able to address the data center issue, not to mention all the racks and the prefabs for all the storage of the servers that you require. And all these racks are intelligent enough to provide the required information in terms of power quality, availability, as well as monitoring, some of the environmental conditions for the servers. All right. Last but not least is the services. How do we provide the maintenance and so on to maintain the data centers that's being run? So if you look throughout the entire company, we do have a complete solution that is available, just for data center. Again, like I mentioned, I'm not able to go into very detail of how to design this and what are the things that we need to look at. All right, this is just to give you a glimpse. If you are interested in any one of these areas to monitor, do let us know. We'll be more than happy to go into all the different areas, whether it's power, BMS, security, or even data center. All right. So at this point in time, I think it would be a good time for me to stop for a short while if there's any questions that you would like to ask. Because I think from beginning until now, we are looking at systems on its own, individual system or individual facilities, infrastructure facilities that Schneider can address. Do you have any questions before I move on?
Please feel free to unmute yourself and ask if you have. I don't see any on the chat still, but we can wait for 1 minute.
So far, so good. Am I moving too fast or am I talking too much?
Good for me. I don't know about everybody, but its speed is good for me. Yeah, so if you have any questions, please anytime during the presentation you can type in, and yeah, CK will address those questions once he's done with the presentation. So maybe CK, we can continue. I don't
All
see any
right.
question coming up.
Okay, so the next section that we are looking at is that for the last probably 20 or 30 minutes, we've been talking about individual system. But today, in an environment, we need to talk about intelligence. When we move into this area, does it mean that in the individual systems which are digitized, they are not intelligent? No. The answer to that question is no. Every system that is being digitized, or the system that I've mentioned earlier on, whether it's power, or whether it's mechanical, or whether it's security, they are intelligent in their own right. So what do we mean by intelligent system now? Let's explore in the context, in Schneider's context, when we talk about intelligent system. Again, I would like to showcase that in an intelligent hospital infrastructure, or in fact in any hospital infrastructure that is well connected today, be it sub-modern or modern systems, the systems that I'm showing on the screen is pretty much being covered in general. Most of the hospitals should have. All right. End of day, most of these systems today, they are already being digitized. Okay, they are intelligent in their own right. But in the context of intelligence, all of these systems needs to be connected. All right. And in this area, EcoStruxure, Schneider Electric EcoStruxure is able to perform that role of connecting these systems together. All right. But today, if we were to talk about digitization, all right, we really need to explore into three areas. We really need to talk about digitization, digitalization, digital transformation. I'm sure most of you, one way or another, have come across these terms itself. All right. But very often what I've realized, and when I work with the global team, we realize that there's a big, what I call, inter-usage between these terms itself. Sometimes they use the same term for different meanings. So in Schneider's context, when I was working with the technical team or the global team and even the IT team, we have come across and we have identified that we should actually define in Schneider's own term, all right, what we mean by these three: digitalization, digitalization, and digital transformation. How does this relate to what we are going to discuss further on? All right. Let's take a look down the line with the word digitization. I think in many countries, especially in Singapore, digitization has been a process for the last 20 years, easily. All right. If we were to track using Microsoft as the benchmark, ever since Windows 1.0, which is way back in 1985, the moment anybody plugs onto a Windows or actually deploys a Windows 1.0, technically speaking, you are already starting your digitization process. All right. So we have come a long way since 1985. So from the very first, when we talk about MS-DOS, where you type in dir stroke w to look at your directories and so on, all the way to today, when I'm able to connect with everyone through Microsoft Teams, we have come a long way. All right. And this entire process is known as digitization. So in Schneider's context, when we talk about digitization, is anything that we digitize. So in other words, you can have a piece of form, a manual handwritten form that we wrote, that we write down and we submit and so on. Once you digitize that form, all right, put it onto the PC so that it can be reused. The information that has been taken can be typed in, it can be stored digitally in the one and in the sense of one and zero. You have already started your digitization process, right? So even if you go into the web dictionary or even you go up to Google, you can type in the word digitization. That's pretty much what they are talking about. So the word digitization to us, as long as anyone that is using a handphone, you are very much digitizing what you are doing. So that's the essence of digitization itself, converting from the physical manual or whatever you see in paper form and so on to the paperless format, okay, or transferring it into one and zero. It's digitization, and that is the term and the understanding that Schneider is going to take. All right. So let's move on further. Okay, so when it comes to digitization, you move backwards and you see today, if you move into any built-up hospital, be it new ones that is completed, handed over, or the old ones, you will probably see different PCs that is being deployed in their command and control centers. You can see probably a fire system there. You can probably see a BMS system there. You can probably see a power monitoring system there. You can see a lot of system. There's a lot of screen going around. Okay, you can probably see a whole rack of table having a lot of PCs running different systems. All right, that is already digitization. But is it good enough? Give you an example. Let's say in a hospital, when there's a code red being announced, normally in the hospital when we talk about code red, it could be anything from a fire alarm emergency to a person, suffer heart attack and so on and so forth. All right. So when this thing happens, you could have multiple systems that are blinking and they are running around. Or okay, where do we start? Which system do we move on? Do we look at this fire system first? Do we look at the security system first? What happens? They are all digitized, right? So the main point now is that there are so many systems, but it's siloed. All right, you take a lot of resources to actually find out what to do, not to mention what is the root cause. You take a long time to find out. So digitization alone, all right, you create a problem that things will start popping up. So in Schneider perspective, okay, in our perspective, when we talk about the process of digitization, we would normally like to integrate all these systems together into one single platform or into one single network. Okay, we can put all the system. That is where when we come into our BMS, what they call systems or EBO or maybe our PSO, we are open. As long as the systems can speak the proper language or the international language or maybe the open protocol that the industry calls, we are able to connect the systems up. All right. So you can actually see it's a long way from the past until now. And even today, if you have old hospitals, if you can bring them to the area, to what they call to the infrastructure or the architecture on your right hand side, you have made a big breakthrough in terms of the world digitization. Right. Having said that, if you are able to do that, you are actually maximizing all your resources, minimizing your maintenance contract or minimizing your maintenance cost, and at the same time, it gives a slightly better control of what you are monitoring. All right. So you can see when we move digitization, we are not only talking about digitizing systems, we are talking about connecting the systems. All right. So that's pretty much entirely when we talk about digitization. Now the question here is, if we are able to, if we have done that and we are able to do it like what the next slide is showing, we have all these systems, we are connecting them up all together within a brand network. Does that make your system or the healthcare intelligent? Right? I'll give an example. Like for example, today, we are talking to one another. I'm the one that is speaking. Probably I'll call myself the HVAC control, and some of you would be probably the access control or the PA control. Just now, there was a reason why I asked the question whether anyone has any questions. It is to showcase the next example here. So if I'm the only one that is speaking, I'm sharing all my information and I'm just talking and doing my own thing and it's going on, and I do not get any feedback. But we are connected in the same forum. It's like we are connected in the same network. Does that make us intelligent? All right. So the word digitalization have to come in. The word digitalization itself is the process of connecting the system and making them operable, interoperable. This is what I'm trying to say. Every single one of us has our specialty. We are specialists in our own way. But if we are sitting standalone and silo, we are still pretty much silo. Nothing is being shared. Nothing is being done. Nothing is going on. Even today, now, if I say that I have a problem, all right, how can you help me? Systems are quiet. We are connected, but it's quiet. We are only digitized. We are not digitalized. The word digitalized is to make sure that every single one of these brains are actually talking to one another. You can make use of the information that I'm sharing today in your own work. And at the same time, when I request for information from you, you can share your expertise with me for me to do my job. All right. That is where the process of digitalization will happen. And that takes a lot of cooperation, that takes a lot of connectivity work, and that takes a lot of understanding, in terms of protocol connection. If you want to, we can spend a whole other section to discuss about this one. We talk about protocols, we talk about logics, we talk about the
correct information or data to be shared. That's a whole different story. But what I'm trying to say is, in Schneider Electric, when we talk about digitalization, is the process of making sure systems are connected and at the same time they are interacting and interoperating. Only when we achieve that, we can say that we do have intelligent healthcare. Going back to the real physical hospital world, for example, when a fire alarm triggers, it triggers an alarm, inform the maintenance people or inform the fire, what they call the fire service, the localized fire service within the hospital to activate. It can actually send information to the BMS system for the BMS system to cut down or to cut off the what they call the outdoor air supply or whatever air circulation within the affected area, so that to staff whatever fire condition that may be, and at the same time probably to cut off the power to the area, activate the emergency power supply to have the lightings to come on. Meantime, lock down, through the send signal to the information to the security system, so that it will lock down the affected area in terms of access and so on, open up all the emergency access going out so that people can evacuate and escape. If we're able to achieve that, all right, then only we can say that we have an intelligent healthcare facility, because it helps human or the occupants of the hospital to save life, to mitigate the what they call emergency, and to reduce the risk of danger. Then only we can say that the facility itself is intelligent enough to help us. So that's the entire process of digitalization. And in Schneider's context, when we talk about digitalization, this is what we are trying to achieve. All right. So having said that, once we are able to do that, we will always try to we will try to put everything into a single pane of glass. All right. In other words, all the information, if we can, go into one screen, or if possible, or not possible, it's actually available today, with proper support from you guys, we can actually design a good interface that creates the last requirement for digitalization itself. All right. We call it digital transformation. I think this word, if you call up in any Google or even what I call Explorer and so on, when you use the word digital transformation, it's not so much about equipment, it's not so much about technology, not the software and so on. It's more about human. It's the changing of the human mindset. All right. I'll give you a good example today is that 2 years ago, when I was still allowed to travel, I've been to one country. Actually what they have done is that it's a brand new hospital. We have activated that. Okay, we have actually commissioned and handed over. What came to me as a surprise was when I visited the hospital, there are maintenance people who are still using, making people run around in the area to manually stop equipment, despite the fact that they already have systems that are connected. The main reason is because some of these maintenance people have been with the hospital for the last 20 to 30 years. They've been doing the same thing day in, day out. Even though when they have upgraded the system, they can still do it in a manual format. They are comfortable with it. So even with a proper, highly intelligent system or highly digitized systems, they are comfortable with what they are doing. They are not using it. This provides a challenge. I've put in so much investment into a good system, but my people are still running around. It is no fault of anybody, but we need to change the mindset of the people. Instead of doing what they used to do, move into the new area that we're looking at. And that's where digital transformation comes in. Digital transformation, to a large extent, is to change the mindset of how people work, how people adopt, and how do we encourage people to embrace the digital technology. That's digital transformation. So one of the thing that I've actually suggested is, the main reason why people were not using the system was because the system was well built. They were full of information on the screen. It's very highly sophisticated, which is good for a young person. But for a person who is in their 50s or even in their 60s at that point in time, they will not want to touch the keyboard. All right. So what we have done is we actually created a few more slides or a few more screen just to cater for these maintenance people, the older ones, where we created just one button. You press a button, there will be a whole series of working down the line to activate an equipment or to acknowledge an alarm and so on. Make things easy. And that's the point of our discussion today, or my point of discussion for this topic. When it comes to digital transformation, as a solution architect like myself, when we go into a system, we do not only look at how sophisticated the system should be, we also should, to a large extent, explore how the interaction between the systems with the people, make it as simple as possible. I'll put in a very sophisticated system, but I need to put in a very simple interface for people to use to encourage usage, so that the system that we put in do not become a white elephant. More importantly, how to entice the usage of the system. The enticement of the usage of the system is what we define as digital transformation. All right. So after going through the last probably 5-10 minutes on this one, what I'm trying to say, in Schneider Electric, when we talk about healthcare, very importantly is the system or the solution that we provided is always meant to be one of the key pillars. It has to be human-centric. We have to entice the usage when we are designing a system, and that's one of the core principles I always hold on to. I can have a very sophisticated system, but if people do not use it, I fail my job. So that is where Schneider Electric will come in, and I believe there's a lot of solution architect together with me, my fellow colleagues, who share the same kind of principles or share the same kind of design philosophy that I'm sharing today. So as a summary, when we talk about the flow of digital energy itself, the what I call the embracement of digital energy, the 3 steps that Schneider provides when it comes to this transformation, I've actually explained, and that's the definition that we have. All right, so moving on. Having said that, today, again, when it comes to the 3 layers itself, when we digitize, we follow the same 3 principles to ensure that the mechanical, electrical, security, network, life science, energy management, the big keyword, all of these are integrated, all right, interoperable, and they must stay, if possible, if we are allowed, they should be connected to ensure that we have an intelligent healthcare facility or infrastructure to work with. All right. So again, I'm going to stop for a short while. Any questions of what I've said? Do you need any other explanation, or was there anything that I've said that was not clear?
There is one question in the chat, CK.
Yep, I'm reading it now.
Okay.
Good question. Fantastic question. This was something that actually I was talking about yesterday as well. 5G. 5G is a very big key thing today. To be honest with you, today, we are hearing a lot about 5G. We are hearing a lot about adoption. All right. To be honest with you, we do not know where is 5G heading in healthcare. But what I could share with you is what I'm seeing today that is being adopted. Again, I will give an example here in Singapore. All right. Due to the pandemic, a lot of the hospital facilities over here in Singapore, they are adopting what we call artificial intelligence. So in other words, even to be more specific, is robotics. Right. Today, in a lot of the government large regional hospitals, right, they are actually putting in robots to actually deliver medicine. All right, to actually move the robot to critical room areas, all right, to monitor patients and so on, so that to reduce the exposure between clinical staff as well as the what I call contagious patients. All right, robots are being utilized, and absolutely right in this question that today there's latency in Industrial 4.0 because of the network, because of the Wi-Fi, etc. Right, there has been a study that is moving on that with 5G connection, all right, this improves tremendously, right? Another example would be there is actually what we call the biopolis in Singapore as well. That's the area where we develop all the high-end biotechnology, bio stuff, etc. It's actually a small township, a very small township that covers probably 16 or 17 buildings. Within that township itself, transportation, all right, all the building controls and so on, all are being centralized to a certain extent, being controlled, and they are already adopting 5G. So a short answer to your question is that 5G is existing today. A lot of work is being done for exploration purposes. I'm pretty sure that 5G, if it carries on without any more political hitches, it will be a big impact to the healthcare world. All right, for sure. Not to mention about all the telemedicine, all the isolation by keeping us close. All of this requires digitization and connection. So a short answer to your question is 5G will impact the healthcare in one way or another. How far it will go, to be honest with you, I have an imagination, but I'm not ready to share with you how it will be. But for sure, robotics, okay, artificial intelligence, remote monitoring, telemedicine will be the immediate benefactor of the 5G technology. All right. So does that answer your question, Edmund? I hope it does, and I hope that's what you've been asking.
Right. So, any other questions before I move on? Okay, great. Thank you. So I'll move on to the next one then. Let's look at very important today. So far we've been talking about individual systems, we've been talking about interconnection, we've been talking about how things should be working, workflow, etc. The key point now is that those are all only operational issues, right? When a hospital is being operated or being run day to day basis, we can say that the hospital is working fine. But bear in mind, is it really true? Whether is it really working fine or not? To be honest with you, nobody knows. All right. And then most of the hospital that have been even very modern hospital today, when you ask them how well is a hospital, they will tell, oh, it's working fine, this works, that works. But when you ask them, do you have any statistics to share? Do you have any pointers to tell me that it's really, following the international standards or the international KPI? I would safely say that 80% of the people that you talk to, no one can answer you that question. And having said that, in Schneider Electric itself, because we have been in healthcare long enough for the last 30 to 40 years, we have accumulated a lot of experience to answer that we really need to have something what we call analytics to actually study the actual working, the actual operation, to come up with proper statistic to gauge, to at least give a reference point of how well we are doing. Now, having said that, every time when I talk about analytics, I get questions like, well, your competition has already offered us the analytics. You can tell us how many alarms that goes on today, tomorrow, within a month, or within the last year, which equipment gives us the most problem. The temperature goes out, or let's say the operating theater, the humidity doesn't reach. Now, to be honest with you, as far as we are concerned, or personally for me, as a solution or as an engineer, that is only statistics. It is not analytics because it doesn't tell you where the problem is and where the next problem will come. Very often in the systems today, if we are really talking about analytics, we need to predict, we need to preempt, and we need to know the historical trend to be able to know what the future is gonna be. All right. So that's where analytics is in its true essence. So when it comes to analytics in Schneider's context, we need to understand the system. How do we understand? The systems needs to be able to tell you where I went wrong or what am I facing. It's just like a human body when you are sick. I can say that I'm very healthy today, you know, but the point is that sometimes I feel giddy, sometimes I feel pain here. Sometimes how often is the pain? What could the main problem is that what could be wrong with me? Is it my heart? Is it my hands or is it my legs? It needs to be able to tell you that. So a system should be able to have something to monitor and to understand its own health, which today many systems do not. Many systems only tell you that, oh, my heart has been painful for probably some time. But how painful it is, it's not able to tell. This is what we are trying to achieve. Understand the systems within the system itself. Identify the correct issues. All right. When we talk about that, again, I will go back to the principle. Let's say, for example, you have a ward which is being controlled by VAV boxes. All right. So let's say the ward itself, sometimes the temperature go haywire. Where is the possible root cause of the area? Could it be the equipment that is failing? Could it be there's insufficient supply coming into the room? Could it be hunting down the line, or could it be something that's happening at the room next door? Right? So this is something that in traditional BMS system you will not be able to tell. You need to decipher it yourself. In Schneider Electric, when we talk about analytics, we are building in the intelligence to be able to do that job for you. And last but not least, we need to see what is the possible thing that's going to come in the future. We need to look at trend. So in an advisor or in an analytic systems, if you are able to have a benchmark down the line for you to monitor how your current performance is moving, you are definitely able to tell whether you're on the right track or whether you're on the right track so that you can do the right correction. That is the essence of analytics, not statistics. All right. So let's move quickly. In the advisor series, or rather in the analytics world, for Schneider Electric, we call them advisor series. They are multiple advisors. We can have power advisors, building advisors, IT, asset, and so on. Question here is sometimes, why do you have so many advisors?
A simple example like today, personally for me, again, I'm an engineer. I'm more or less on the mechanical side. If you were to ask me about the electrical, I do know superficially, but I do not know the in-depth. So how can I tell you in depth of a problem of a power without having that knowledge? This thing applies to the system as well, because in a hospital we have electrical power, we have mechanical control, we have IT systems. Every single one of these will have their own, unique knowledge, a unique way of dealing with things. That's the reason why you need to have different specialists, different advisors, or different system to actually monitor and provide you with the right context of that domain itself. And that's the reason why, in Schneider we have multiple advisors. And it also to showcase that the real reason why we are able to do that also, Schneider is one of the very few company that I've always been saying since the beginning of this presentation, is that we provide end to end. We provide power, we provide electrical, we provide mechanical, we provide IT. We have the knowledge to go that expand, and we have the people, and that's the reason why with this knowledge we're able to come up with the proper analytics for the different domains, to address the challenges that you might face. Okay, so in terms of the advisor, what are the solutions or what are the things that you provide? Definitely service plan. All right, we are talking about maintenance. And over here, maintenance is not time-based maintenance, it's actually predictive maintenance. All right, you can actually, in the past, when we talk about maybe a transformer or a panel that needs maintenance, probably every 12 months you need to do it, or maybe after 10 years you need to replace the transformer, or maybe 20 years you need to replace the main incomer. But the question is, do you really need to change the thing when the time comes? Because if along the way you have operated the things properly, you have done the things correctly, they may age less or less faster compared to the others. So when the time comes, when the manufacturer's predicted time, if you did the job well, you could have extended the lifespan of the asset, all right, which you can continue to use. So with the proper analytics, you are able to find out whether the systems could be pushed beyond the limit of the boundary, because every single year that you can push the assets boundary, it means a certain amount of savings for the facility, which will convert into revenue being generated for the hospital. Some of you might be asking, we are talking about life, we are not talking about revenue in a hospital. Yes and no. Priority will be life, right? In a hospital we talk about, but reality have to also come into the fact that every hospital has to be sustainable. So how do you sustain a hospital? It's through revenue. Every single revenue that you can save for the hospital, you can actually sustain it to provide longer support, better, life management or life risk management for your patient. That's where it goes. All right. And then of course the most important thing is that the advisor series, if you sign on, or if we sign on, if you work together with us to a certain extent, we do provide a specialist to give you the right support that is needed to extend, the operational of what I call lifespan of your system. Okay, last but not least, also the actionable insight, all create all the national warnings and so on, tell you what is going to come, what is going to happen down the line, predicting what is going to happen. We cannot tell you what will happen, but we can definitely predict what might happen. All right. So that's what advisor is all about. All right. Just to share the next few slides is some of the examples, some of the reports that we are going to provide for the different advisors. You will see all kinds of things like what are the top 5 issues, the immediate things that you need to look at, the immediate things that you need to resolve. What are the recommended actions? All right, what is the expert opinion? What do we think that it might help you that you can do? Because whenever we look at advisor, we do not only look at your system, we also look at the whole entire implementation, so that we have a what I call a better understanding of what your facility is, and that's the reason why we are able to provide you with, the corrective what I call actions that is recommended. There's trend and summary, and again, there are all statistics, snapshots of evidence, and so on and so forth, depending on how far the data that you have been collected. All right. So the bottom line is that up to this point in time, we are connecting systems. Okay, we are collecting the data. We are doing this very, very well through the digitization process. However, without analysis, data is only data. You need to transform the data into information. You have to analyze the thing to give you the information for people to do so that it can take action. Very often, I would like to caveat here. I have come across a few times question that tells me, so CK, when we put in analytics, when we put in advice, so the system will be able to to do the corrective action. Now here I would like to really put in a caveat. In Schneider's perspective, when we talk about correction, is we talk about operational correction. So in other words, it's like set point adjustment, those operational issues. However, real corrective action will still need the decision to be made by human. It's not that systems cannot do it. Today with artificial intelligence, we talk about augmented reality and so on. Systems can do. In a hospital perspective, in a real sense, I wouldn't want to put my life at the hands of a machine. I would still like to have the decision being made by the right people, because no matter what we say, artificial intelligence is still artificial. Nothing beats the human brain. So in this context itself, when we are talking about design, when we put in an analytics, we will do the first three. We will connect, we will collect, we will analyze the information. When we say we take the action, the decision needs to come from the users themselves. We will provide you with all the statistics, provide you with all the information, provide you with all the recommendation. Decision to take the action and what action is to be taken needs to be taken by a human. All right. So this is the caveat that definitely I will put in. I'm not sure about the rest of the people, but over here, when it comes to healthcare, this is one thing that I would really like to clarify. No patient or no system on earth or no operators in the hospital will leave any major decisions to a system. All right. So this is just a caveat. So this is what I call this slide that I'm showing. When we say take action, is to take the right action by the users. All right. So that covers pretty much what analytics is all about. All right. So again, stop here, and I saw a question coming in from Susie. Good, good to have you on board, Susie. Thank you for joining. All right. Your question in Malaysia. Oh yes. To be honest with you, in the past year I've done quite a number of presentations for some of the hospitals through my fellow colleague, and most of them are actually pretty interested in this, in what I've presented today. The issue here is that it seems like it is still a pretty new concept in the Malaysian context, because I've also seen things that they are talking about industrial revolution. Pretty much industrial revolution, if I'm not wrong, is a Malaysia's government policies core term. But how is it being adopted into healthcare? There's still rooms for discussion or planning. All right. So in fact, in Malaysia, when we talk about it, just to answer your question, digitization is already there. A lot of the hospitals already have the BMS, already have the power. The road itself would probably be digitalization. And last but not least, the digital transformation itself. All right. So if you would like to explore this a little bit more, I'm more than happy to share with you down the line. All right. Does that answer your question, Susie? Thank you so much. All right.
Thank you, CK.
Thank you. All right. So if not, due to time, I'll move on quickly now to cybersecurity. Today, as the moment we talk about digitization, if I do not touch on cybersecurity, then it is definitely not fair, and it's not doing justice to what we are trying to achieve here in the digital energy. All right. Let's look at what's driving the industry. Standard connectivity, mobility, cloud analytics. This is something that we are doing day in and day out. We are seeing it. Having said that, we are also, the moment we are so well connected, especially in the digital realm, we are also exposing ourselves to a lot of threats. And that threat is coming from the cyber world. Because the moment we go into IT, we go into the digital world, we are moving into the cyber world. And within the cyber world, like any, there will be criminals around. Right? There will be, worst case, there will be terrorists around. Right? So in order for us to move into that world, into that realm itself, we also have to be properly secured and properly monitored. So that's where we have to talk about cybersecurity. Okay. A quick short analysis, in Schneider's context, when we talk about cybersecurity, all the necessary protection and so on, like password protection, password changes, automatic logout, handshaking, SDL, DSL, TDL, you name it. Most of the recommended IT world standard in cybersecurity is being adopted by, in one way or another, by our system to ensure that our system has minimum, compliance or protections against cyber threat. So the slide that you are seeing now gives a standard example of what are the things that we follow and what are the things that we are doing and so on and so forth. I can't go into very detail on each and every one of this because it is being adopted differently. All right. However, just to give everybody's what I call security, most of our system, or in fact all our systems that we are provided, all the solutions that as long as it's IoT based, we adopt in one way or another the industrial practice of the cybersecurity requirement that is needed within that industry itself. So just to move a little bit ahead, very often why do we need to share this? This is where we are pretty happy to say that we are slightly different compared to our competition to a certain extent, is that most of our competition that we've been hearing in the market, right, they addresses cybersecurity from cloud to management to technical, whereby it's up to the controller level. That's pretty much where they will stop, right? In Schneider's context, we move even further than that. We move down to the OT level, which is the field devices. Because today, when we talk about IoT, there are many sensors that are being connected IoT, Wi-Fi, you know, what I call socket placed with IP addressable sensors. You can have one. Today, one of the sensors that we see today could be as powerful as our, well, I would safely say as our handphone apps to a certain extent, and this definitely IT based. But the moment when we talk about IT or we talk about IoT, as long as you're connected to the network, you are prone to any cyber threat that is available. All right. So an example that I've heard, when I was doing my trip in the US, there's an example in a university. There a student was able to hack into the university's mainframe to get questions just through connecting to a sensor on the wall. All right. So that's how big a threat is. Now it may sound strange and it may sound funny, but I've been told that it's a real story. So whatever that we see in Mission Impossible is not really impossible. It could happen. All right. So coming back to the real world, in a sense, in Schneider, we recommend, oh sorry, we understand that. All right. So that's why when we address cybersecurity, we go all the way down to the sensor itself. To a certain extent, we will comply to the what I call cyber standard that is required for sensors and for IoT, not to mention all our Wi-Fi devices or all the application that's available down to the room level. Right. So this is where I'm very proud to say that, especially when it comes to healthcare, it provides the extra security, for the healthcare industry, right? So a very common topic, if we do not stress the standards that we are following, it doesn't do any what I call justice to our cybersecurity team. So in Schneider Electric, we follow IEC 62443. Now, I'm not able to tell you what is IEC 62443 because I've not read the specification, but I'm pretty sure, in the world, in the IT world today, or in any industry today, IEC 62443 is so-called one of the most recognized cybersecurity standards that is being adopted by all the market. All right. So I'm proud to say that in Schneider Electric itself, we do follow IEC 62443. Now, if any one of you who are interested in more detail of what this slide is all about, do contact with Manishi or my fellow colleagues in your local country. I'm sure they can actually organize someone who is specialized in this field to share with you. Right. As of now, just take it for the fact that all our product is in one way or another complying to IEC 62443 in their respective context. Right. Okay. This slide, I'm a bit passionate about, okay, when we are talking about cybersecurity. Now, if you look at that, there's this 5 deck that we are showing. Cybersecurity actually is a threat to all these different areas. The perimeter, the internal network, the host application data, be it software or be it hardware. Cybersecurity to a large extent, offers threat to this area. And in Schneider Electric, especially when it comes to the healthcare environment, we do have a specific group of people that can actually address these issues. So if any one of our client or any facility requires certain form of guidance or certain form of support or certain form of working together, we do have a team to do that. And in general, we call it physical security. So we can actually pretty much address what I call find out where are the flaws, whether down to from the network, the physical network, down to the software. We can actually identify the threat and actually probably recommend, what are the corrective recommendation or corrective work that needs to be done. We do have this group of people and they are very highly specialized. I've had the fortunate, what I call opportunity to meet with this group of people. So they really they tell me things that I don't even recognize, but they are able to do that. Now, having said that, I've come across questions. So if let's say I were to adopt all the recommendation itself, Does that mean that my system is fully secured? Simple answer. I will probably guarantee you 98%. There's still that 2% that will not. That threat doesn't come from the system that we provide or the recommendation. It comes from the users themselves. And this is what we've called the policy, procedure, and awareness. There is a statistics in the IT world that actually mention 90% of cyber attacks or breach in cyber systems itself is due to human error. And very often is due to the lack of administrative or the enforcement of the procedures that are being put in place. Simple example today, I can put the most advanced cyber security system on my PC, but if my daughter comes in, uses a USB plug into my machine, copy a file and goes out, either she copies the wrong file or she puts a virus into my system, I'm done for, because I did not enforce the fact that she should not do that. All right. So to bring it into a larger context, if the policies and the procedures put in place, like you are not supposed to copy any files out of the system, or when you go in, you're not supposed to use anybody's password to give you access to it, the system should be safe. But if those are not, being done or being put into place, all right, no matter how good a system you put in, it will be breached. All right. So in Schneider Electric itself, we are fully aware of that, and that's when we always say when it comes to cybersecurity, it is not Schneider's sole responsibility. It is a common shared responsibility with the partner. All right. Last but not least, there's another point to note also, because we are talking about healthcare. I need to stress this as well, and this is something that I've passionately shared with our global team as well. If you read the sentence here, the key point is cybersecurity is a life cycle process, it's a life cycle exercise. All right. Maybe the words are too wordy. I'll put it into a human context. Again, as a human, like myself, I do have some medical issues. Okay, not major, but I was born with it. So now with the pandemic situation, when it comes to the vaccine, when I take the vaccine, I really need to go to my doctor, my family doctor, to ask whether I know or not, or whether I'm suitable for the vaccine to be taken. Reason is very simple. I have a new virus, I have a new remedy. I do not know whether my body can take it or not. So only my doctor who has seen me from young until now knows how my body really is, to be able to tell me, okay, CK, you can go, you can take the vaccine, it's not going to harm you. All right. Very often today, a lot of people, I've asked this to a lot of my friends and even some of the patients that I do not know, why do you not want the vaccine? A critical condition is they do not know what will happen to them when the vaccine goes in. And the very reason is because they do not have somebody who is able to advise them. So if today you ask me to go to any GP to ask them whether I can take the vaccine instead of my family doctor, I can assure you I will not take the vaccine. Coming back to cybersecurity is the same thing. The system that you are being put in, the person that is enforcing or applying or adopting all your cybersecurity requirements will know your system inside out. So when you do a change or when there's a new threat in the market, if you deploy somebody who doesn't know your system, they may recommend a solution or a vaccine that is not suitable to your system, which worst case, you will probably just stop your system from doing something. Worst scenario, it may even crash your system if the solution is not done. So what we are trying to say here is that anybody who is addressing cybersecurity itself, you need to look at a partner or a cyber specialist that you can work long term, because your facility could run 20, 30 years. You need to have a family doctor, when it comes to this threat itself. In real life, in human, we are talking about biological virus. In the cyber world, we are just talking about digital virus. The difference is one is one is carbon based, the other one is 1 and 0 based. Both are viruses. They mutate and they change. So vaccines or what I call antiviruses needs to change over time, and you need to have the right people to help you. All right. So that's the what I call key message that I would like to bring across when it comes to cybersecurity. Ben, because I'm dealing with digital energy, this is something that we have to address today. We have to understand today, and we have to move on. All right. Fantastic. And thank you, Raymond. Thank you for agreeing with me. Thank you so much. All right. So before I move on, any questions? Before we look at the applications itself. So far, so good. Okay, let's look at key applications. Okay, in a hospital facility, there's all the different parts. There's so many different parts that each an individual what they call facility requires different kind of control. For example, patient room, you definitely require light control, you require temperature control for sure, fire detection, nurse call, etc. And then if you go to the more critical rooms, like for example the operating theater, you definitely need medical UPSs, right? You need to have fast response temperature control and humidity control to ensure that the pressure is controlled proper, right? And also you need to have air quality monitoring, right? You definitely need to have good air quality within the operating theater, not for the not so vocal for the safety of the patient, and at the same time, more importantly, to the clinical staff, because very often they are working under high stress. Oxygen level is very high. You need to have proper air change within the room to provide the right oxygen level so that the doctors can work properly and their eyes will not go blur or whatever. So that is very important. And also you need medical monitoring, medical gas monitoring, etc. So in all these facilities, they would have their own unique requirement when it comes to the infrastructure. And in Schneider Electric, we, in one way or another, we do have a solution for them. That's the reason why I keep on saying it's end to end. All right. So just a few of the applications that we can see: building management. Okay, we talk about pressurization control for an ICU. Right? So you have all the negative pressure, and by doing proper pressure control, you are actually controlling the airflow direction. So in other words, you are moving or removing the harmful material in the right direction so that it doesn't harm the patient or the user within the room. So proper pressurization is required and proper pressure regime is required to ensure proper airflow control, right? How about power? Again, without power, nothing works. So you really need to monitor properly where the power is coming from, what is the quality of the power, and how much is the usage, whether you're using excessive. Now, the reason when I say using excessive is so important is, of course, cost is a big deal. The more excessive power that you use, the more what I call money you have to pay. But the thing is that another key point of monitoring the usage of power is excessive power could also mean that your equipment is having a problem, right? So it gives an indication of where the problem could be with excessive power. So proper monitoring of the power not only saves you money, it also tells you where is the possible risk, right? So proper power management is very, very important. Okay, and also we talk about emergency lighting. In any hospital, emergency lighting is very, very important. In a shopping center, when we talk about emergency lighting, if the emergency lighting is not working and so on, people will find their way out because they are healthy. In a hospital, all right, you have sick people who cannot even fend for themselves. So if you do not have proper lighting or proper guidance for the caregivers to be able to move the patient out in a safe manner, you are actually putting people's life at stake. So every time when we do, when I'm designing something for a hospital, two things come into my mind: emergency procedures of the hospital and what are the solutions or the system they put in. One of the things that comes into play would be the lighting. You have to ensure that the lighting is always working, backup upon backup. When something happens, the only thing that is going to save the caregiver as well as the patient is the light, right? And also, I've mentioned earlier on, we talk about very expensive equipment. I think what you are seeing here, you are seeing a CAT scan machine as well as an MRI machine. So all these machines will require backups upon backups. They will require specific cooling requirement of the environment as well as the equipment themselves. And at the same time, the power utility that is being provided to it has to be crisp, has to fall within the right specification, and it has to be reliable. All right. So within that itself, we do have solutions for that. And if you look at it, you have the UPS that is being provided. You have all the what you call data racks. Nowadays, because of all these machines, they are all digitized. You need to have certain areas to store all the data. Now, when I showed this slide about 3 weeks back, someone asked me, if we have a data center and all these equipment are being protected, wouldn't the data center be enough for storage? Yes and no. All right. Normally, in most of the hospital that I see, which they are able to do it, they would like to keep the data center as close as possible to the equipment for two simple reasons. You are distributing the risk of the storage, and at the same time, you are also distributing the locations of the equipment, making it closer so that the latent or the crash or the corruptions and so on comes less. Because the closer the storage facility is to the equipment, you have better, safer data storage. And at the same time, if you can provide a data center together with a more localized data rack to store, you can actually provide carbon copies, right? So in case if something were to happen on one side, you still have a backup or you still have another copy. In the medical industry itself, backup N+1, N+2, whether it's for equipment or whether it's for medical information, is crucial. So this is where we do have the right solutions to address all these backup requirements when it comes to data, right? So this is more towards all the critical equipment and of course CCTV, all right? Nothing beats, a picture says 1,000 words. A video will tell you the whole story. All right. So in our world itself, when it comes to card access, we are able to connect not only to the card access, we are able to connect most industry communicatable video to provide visualization to the hospital operators, and also at the same time to do playback and recordings if required. All right. And of course, IT I mentioned a lot already. Data centers, we do have a data center solution for it. And building open architecture. Okay, one of the key things when we need to monitor is definitely gas monitoring. And gas monitoring, to be honest with you, Schneider Electric, on our context, we only monitor, we do not do control. Because gas system itself is a life safety system. Normally, we only do monitor, we do not control it. All right. So in other words, the system that we are provided, or Schneider's platform, the EcoStruxure platform, is open, all right, to be connected to any system for monitoring, all right, control to a lesser extent as and when required, but we can actually connect to any system that shares the right protocol and right languages to use. So one of the example would be gas monitoring. Okay, just to give a context of how this thing is being adopted, I'm going to share with you a critical environment, and what you're seeing is actually a hospital. So the main things that we can actually provide in is the main power as well as the lighting control. In an operating theater, lighting control is very, very important. In any area, let's say for a ward, it's probably on and off. But in an operating theater, light intensity is crucial because it depends on the operating procedure that you are being provided. The lighting intensity will affect the clinical staff, especially the doctor when he's performing the procedure. So you probably need to dim out your surrounding, just leave the concentrated light on the operating table, or you will need to have the entire light being turned on to a certain intensity to ensure that all the nurses and so on knows what they are doing and is able to see their stuff. So all this requirement is there. So we are also doing the lighting control for the operating theater. Okay. Next, the PMS management. Simple. Monitoring of pressure, air change, temperature, and humidity control. Standard. Especially when it comes to pressure within an operating theater is the key. For us, I do not want bacteria to get into my body when my doctor is actually performing the operation on me. All right. So pressurization is very important. Make sure that the harmful material stays out of the operating theater when the procedure is being done. All right. So that's where the BMS system will come into play crucial. All right. Then we talk about card access. I'm sure you do not want somebody that is not authorized or not supposed to be there to be able to barge into the operating theater to affect the room. All right. So card access is probably one of the thing, or at least you should monitor who is entering, who is going out. All right. And of course, we talk about medical systems. Medical gas was one of the systems that I've mentioned. There are many more. You can talk about the surgeon system. You can talk about the what I call the I can't remember the heart monitoring system, or the pumping gas systems, or the oxygen supply system. Okay, we need to, if possible, the surgeon would like to see, and if we are able to connect that, we can actually project it onto the surgeon what they call the surgeon panel. Okay, which I will show you later. All right, definitely secure power. Again, like I mentioned, operating theater cannot fail. So when we talk about that, we have to look at the UPS. When the main power or main utility fails, okay, the UPS will need to kick in for a period of time. All right, I think the requirement for the UPS has gone up from 30 minutes to an hour today because of the complex procedures that we are having, and even the complex equipment that is being provided there. And not to mention also, we need to have backup cooling units. All right, if your main AHU fail or your main aircon fail, you don't want the patients inside there, to start sweating, especially doctors, because they are fully gowned. It's going to be hot. You cannot have no cooling. And the other thing is that proper cooling will benefit the patient because it stops the heart, or rather it regulates the heart, because as temperature starts to fluctuate, our heartbeat changes. We need to maintain the temperature as smooth as possible or as stable as possible to prevent any shock. All right. So when the main fail, you need to have the backup to be running to ensure that the temperature do not fluctuate as much as what I call as dangerously as stipulated. And last but not least, like I mentioned, if you're able to connect all this, you can project it onto the surgeon panel. Surgeon loves to have this kind of information because all this information will affect his decision on how the procedure will proceed. And at the same time, it also regulates how the nurses is able to respond, when situation come. More importantly, anything were to happen, the maintenance people outside will be already on standby with all the backup procedures available. So with the connected system that we have shared, we are actually activating all the required people to ensure one thing: life is not lost. All right. I'm going to highlight this again and again. Life is very important. Okay, the handphone one is something that I'm not going to go into too much, but that's the basic thing. Last but not least, we do not talk only about one hospital. You could be a hospital group. You could monitor, or the central management system could monitor multiple hospital in multiple locations. I'm very proud to say today in Asia, we do have such an example, which is happening in Indonesia. Unfortunately, I do not have the authority to share it here today, but I can share with you, we do have a hospital group in Indonesia. You can, if any one of you who is staying in Indonesia would already know. Those of you who do not know Indonesia geographically, Indonesia covers probably the size of almost as wide as Southeast Asia, with multiple islands all over the place. This hospital group has hospital across the entire archipelago. And today, we are really, really proud to say that a Schneider system is there monitoring, centralized monitoring for all this hospital group across the archipelago. All right. It is not something that I'm I'm coming up. It is not something that is done in the West. In Southeast Asia today, we do have such an example. All right, and this is exactly what I'm showing you on the screen. Centralized location in Jakarta, monitoring the entire hospital group, okay, within the entire Indonesia archipelago. All right. Okay. Up to this point, any questions? So far, so good. Let's look into the future. All right. We have done a lot. We have seen a lot. And today, like I mentioned, in Indonesia, we do have a very wide area network coverage. Is it the future? All right. It's not. The future is yet to come. I think in most of you who are in Malaysia will understand this term akan datang. It's coming. Let's look into the future of what the healthcare is going. We need to have a next step of thinking. In fact, COVID-19 itself, one of the good things that actually came up from COVID-19, apart from all the bad news that we've been hearing, it actually, because of this pandemic, it has actually pushed forward how the future will look like. And it also raised a realization that how the future should be. Because today, when we talk about COVID-19, it is a highly infectious disease. Whether or not it's airborne, it is still a question mark, but it looks like it is, all right. But unless WHO declares it, I'm not going to say it. But what I'm trying to say is highly contagious. And the only way today, the real tool that we can actually go against all these infectious diseases is through isolation and containment. One way or another today, all of us around the world today is being affected, or we are under isolation and containment. A good example will be myself today. I'm actually advised to work from home because I'm doing the regional role. I'm actually being advised to work from home. For what? Is to isolate myself and to contain myself from the rest of my co-workers so that I myself is safe. And at the same time, if I'm carrying a virus, I do not infect the rest. So the point is, isolation and containment is going to be the future. It was the past, it's now, the future will be the same. The only way to break the chain of infection is through isolation and containment. But then again, we are human. No human is an island. We need to be connected. Digitization, the future itself is where we are talking about. And likewise, like today, I'm from home. I'm talking to every one of you who are around this region. It's through digitization. So the next step would be digital twinning concept. Is we are going to utilize whatever that we've talked about, digitalization, digital transformation, to transfer into another realm of what we call digital twin, right? Some of you might already be familiar with this, right? Some of you might not. So for the benefit of those who have not, what is digital twin? Today in a physical hospital, if I were to share with you now, let's turn off the power and let's see what happens to the whole operation. Let's find out the gap. I'm very sure that you will not be able to get the permission to do that. All right. And when I say turn off the power, it's not to a zone. It's turn off the main incoming power. Let's see how the hospital will react. No one in their right mind is going to do that for running an operating hospital. No way. All right. So this is where the future is going to come in, because today we really need to do that, because you never know when the next pandemic is going to happen. All right. I'll give you a good example. Singapore today, we have gone through SARS in the past. A lot of what we are documenting, or a lot of what we are doing today to address the COVID-19 issue is based on the experience that we have done in SARS. All right. But that exercises itself was through a long time, was through an experience. Even when COVID-19 started, or when COVID-19 broke, all right, to a large extent, I can share with you, a lot of hospital doesn't know what to do. There was no way to find out what might happen. There's no way to see what is going to happen. So this is something that, because of this pandemic, it has pushed the boundary way much faster than what we anticipated. Digital twin is a technology that's already readily available, but they receive a push, and it is now being adopted in a lot of healthcare facility. How do we do it? We are going to digitize a physical hospital, bring it into the digital realm. So in other words, you have a mimic copy of the hospital in the real world, in the digital realm, and that's where you can actually mimic all the different kind of scenarios and facility. So the minimum word that's required for digital twin is that it changes the physical realm, bring it into the digital realm, and to create a real-time environment for you to actually simulate and do what is required. So the future is the contextual model. So now again, if I were to come back and say, okay, let's test this now, let's cut off the main utility power and let's see what the hospital is going to do. Because of all, with the right data, with the correct data that is being collected, behavior and so on, all right, we are able to simulate that kind of scenario and see what is the outcome. So we are trying to predict the future. This is what the digital twin concept is all about. And this is going to be the future of not only, I think, not only for healthcare, it's going to be many other worlds or many other segments. So coming back again to healthcare, all right, one of the key things that we need to do is that today, in Schneider Electric, we are talking about only the infrastructure. In order to have a real essence, what I call the real happening, or the real thing that's going to really affect, to give the output for the digital twin, we need to connect to the clinical world as well. So we need to connect both the infrastructure with the clinical systems. All right. And this is where we go. The digital twin enables. First thing is that the clinical system is very important. All right. That's where we talk about the patient, we talk about the caregivers. So we need to look at the IT, whether the IT can support the kind of big data chunk that we are talking about, the big data collection, medical devices, sensors, and very importantly, admin. Because in the hospital world, compared to any other building like shopping centers and so on, there are two things that we are looking at. All right. In a normal building, offices and so on, we are talking about the public, we are talking about healthy people. In a hospital world, we have another perspective. We have a combination of sick people, we have a combination of public, and one more thing, we have a combination of very infectious viruses. All right. So when it comes to administrative, this is where there is a merge between the public as well as the patient. All right, so we need to know where is the administrative. And when we talk about administrative system, it's actually the entire administrative process. From the time you register, you walk through the corridor to where you are being admitted to your ward, and from your ward out all the way to your operating theater, blah, 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 all those kind of stuff. It's the entire ecosystem for the administrative system, because this is the data that you collect from there is the one that is going to be what I call put most into the digital twin. Okay, just so to cut the whole thing short, all these systems needs to be connected. We will include all the reasoning, all the KPI to form contextual. And when you change the reasoning, in other words, you change the parameter, that's where it will generate the outcome that will show you what is going to happen safely, okay, without antagonizing anyone. All right, so this is really going to be the future of what you're going to see. Just to give a snapshot of what the outcome is. All right, we will have a lot of different sources. You can name it IoT system, IoT sensors, people. All right, people. You need to do survey. You need to monitor. You need to observe. All these are data which will be collected from many different systems which are talking in different languages. They are connected REST, okay, backnet, jets, and in the what I call in the medical world, we always talk about HL7 because it's one of the most common protocol that's being used, right? All these are languages that are being used by different systems. We need to understand that. We need to have a common what I call understanding or gatherer, or you call it interpreter or whatever, to collect all this data, okay, That's where we adopt and apply all the required resources to convert all this data into meaningful information that can be exported out for the users to see the scenario that is going to happen. Right? So this is the digital twin component as a snapshot, as a very, very big overview, of what needs to be done behind the scenes, Then we can actually simulate and put in and adopt the different kind of processes. That's where we can come up with a proper workflow to ensure the proper operations of the healthcare facility. We can reduce waiting time. Okay, we can ensure management of the patients itself during normal condition, and most importantly is during emergency time. Okay, be it a pandemic or be it an accident or be it a natural calamity, when this kind of inflow of patient, what is going to happen? Right? Okay? Shift allocation. All right. All these are interrelated, which can be simulated, okay, through the digital twin, what I call concept or platform, to see what is going to outcome, so that operators of the hospital can adopt the right actions and what I call procedures to address those issues. All right. I think for time constraint, I'm not going to ask questions here. We can come back later. So one of the key things that in Schneider Electric that we are different from others is solutioning. Right? I think today, from the beginning of 9:30 until now, we have been seeing a lot of chaotic things. I've been sharing with you a lot of data. You can see a lot of 1 and 0 going around. Nothing is firm. All right, it's still in a mess. Right? But what we need to do is to be able to put in a right solution so that there's right interactions between equipment. We have to put in the right reasoning and the business processes in to be able to give you the proper output. All right. So today in Schneider Electric, I'm just giving you a snapshot of what are the products we have. All right. Now, if I were to go into this product, or if any one of the solutions architect that you will be talking to goes directly into the product to share with you what the product can do for you, this is not what Schneider is all about. Schneider is all about solution. We have product. We have tons of products. Right? What you are seeing is just a snapshot. It's just the tip of the iceberg of what we can offer. So when it comes to equipment, products is just a tool for you to manage your, what they call, to address the gaps or to address the worry that you have. Important thing is what is the solution to put across. All right. So that's where EcoStructure comes in. We put in solutions into the different right domain. We have the right specialists to work with you. The important thing is that it's solution based. So my role as a solution architect is to come up with solution, is to talk to you, is to understand from you, and that's what Schneider does. We are more than happy to hear your problem. We are more than happy to hear your gaps. We are more than happy to hear your pain point. All right. We hope to be the doctor that is here to help you, to solve the problem that you have. So solution is the key thing. All right. So as a solution architect or any solution architect that you talk to, the key thing is that we would like to hear from you. You will probably get a lot of questions from us, not because you want to be funny or want to make life hard for you. We want to understand your problem. I'll give you a simple scenario. We are talking about healthcare. We are talking about doctors. Today, if you feel that you have a headache, you're running a fever, you go to a doctor, the doctor immediately prescribes you Panadol or painkillers or whatever. Will you have the confidence to take that solution? That's the key thing. But if you go to a doctor that can ask you, right, how do you feel? Which side of your head is having the headache? Which part of your body is painful? Are you vomiting? Do you have stomach ache? Is your body aching? Hands, leg? The more question that he asks, the more information that you provide, the more he can tell you what could be your problem. So end of the day, when he prescribe you the same thing, you've got a common flu, Panadol will do the job. I'm pretty sure you will be more than happy or more than confident to take that Panadol compared to the earlier doctor. And that's what Schneider is trying to do. And that's the reason why in Schneider we have solution architect, we have system architect to be here. So end of the day, what the big difference between us and our competition to a large extent is that we have this group of people here together with all our other fellow colleagues, with our sales and so on, to work with you through the solution. So end of the day, the whole context that we have is that we are a solution-based energy company. All right. So we do have proper tested solutions that we can use. We do have the medicine ready. All right. But we need to understand your symptoms in order to provide you with the right solution, or maybe what we call it in the medical book, the right medicine. All right, last but not least, just to summarize what we have done for the last probably 1.5 hours is that in Schneider Electric, we do have all the architecture, the equipment, in other words, we do have all the medicine available. All right, we do have the software. We do have the right prescription for you. All right, we do have the right prescription. The key thing is, all right, we need to understand from you what is your pain point. And last but not least, we do have the right people here, of the different specialist domain to be able to understand what you're trying to share with us. It's just like, again, in the medical world, you have the GP, which normally covers everything. You do need specialists when things goes bad. All right. And in Schneider, we have that. So I'm pretty much like the GP. All right. I'm not a specialist. So I'm a jack of all trades, master of none. But then again, I'm able to understand your pain point and be able to share with you. If I realize that there's something wrong, or if Schneider realize there's something wrong, I will find the right specialist for you in-house, okay, to be able to share with you and to address your issues. Okay. So having said that, I've spoken quite a fair bit. All right. Oh yeah, that's the last one. We have the design, philosophy, and methodology. So in other words, we have the medicine and we have the prescription. Important thing is that give us the opportunity to work with you in healthcare. All right. So having said that, Q&A. If you have any question, I think we have 15 minutes, more than enough time. All right. Please feel free to ask any questions or anything that is bugging you, or even if you have a pain point, if you would like to share, more than happy to address it. Anyone?
Don't see them coming, but it was really very clear presentation, to be honest, CK. So I mean, we'll just wait 1 minute more. If somebody has any question, please feel free to unmute yourself. Or is there any feedback or comment? Just let us know. Okay, I think apparently nothing is there. So thank you again, everybody here Friday morning. I really appreciate this time with Schneider that you've spent. And much appreciation also to you, CK. It was an excellent presentation. Thank you, everybody.
I would like to thank everyone as well, for the time. Hopefully it has been a bit beneficial. I have not bored everyone. So thank you everyone for the opportunity to hear, for me to share with everyone. Thank you so much. And thank you, Manishi, for the opportunity.
Right. Now we will just have another last session of this series in starting in 10 minutes. That's on the ETAP software. There'll be a designing and the demo on it. So please do join in. I think you must have gotten the link by now. So we'll see you there in 10 minutes. Thank you, everybody then. Bye-bye.
Thank you, everyone. Have a nice weekend. Bye-bye.